Titration reactions, great to us. Hello, everyone. Titration reactions are one of the most important chemical reactions we have in chemistry, simply because they enable us to determine the unknown concentration of a certain solution, to verify a label on a commercial product, and to determine the percent purity of a commercial product. Commercial products could be commercial solids, or they could be commercial solutions. The titration setup that we're seeing right here, it simply consists of the graduated burette. We have a stand right here. We have a stand right here and a clamp. This is the stand, that's the clamp. We've got an Erlenmeyer flask. We've got the magnetic stirrer and a bar magnet inside the flask or the beaker to stir the solutions or agitate them together in order to have a great contact between the two solutions. Let us just consider the titration between potassium permanganate solution represented by the MnO4- ion, with the K plus being a spectator ion, and another solution of Fe2 plus 2Cl minus, represented by the Fe2 plus ion placed in the flask or the beaker down below. Now, a certain volume must be taken of the Fe2 plus 2Cl minus solution and poured inside or into the flask. Now, we need to use the volumetric pipette because of its high accuracy. So we measure a certain volume of that solution and we pour it in the flask or in the beaker. The burette is filled with the potassium permanganate solution. To start the titration process, we need to start the magnetic stirring right here, and we need to open up the stopper to allow this solution to start to drip right into the flask where the Fe2 plus ions are. A reaction takes place between the MnO4- and the Fe2 plus. When you balance this equation, you'll notice that you have MnO4- and 5 Fe2 plus ions. At the point of equivalence, which is the point at which the MnO4- ions and the Fe2 plus are both limiting, the number of moles of the MnO4- added from the burette equals to the number of moles of Fe2 plus in the beaker divided by 5. Now we need to replace the N with the C and the V. Let's just say that the legends for the potassium permanganate solution in the burette are C1 and V1E. V1E represents the volume of the potassium permanganate added from the burette to reach the equivalence point. And of course, the C1 is the molar concentration of the potassium permanganate solution. In the beaker, the volume of the Fe2 plus is known, but let us just consider that in this case that the C, or the molar concentration of the Fe2 plus, is the unknown. So the legends that you have right now, for the MnO4-, you have C1, V1E, both are known, and you've got C2 unknown for the Fe2 plus, and the V2 is the known volume that you measured with the volumetric pipette and introduced it right into the flask. How do we observe the equivalence point? The equivalence point is observed when a sudden change takes place, sudden change in the color that is, takes place inside the flask or the beaker. For example, potassium permanganate has an incredibly beautiful deep purple color to it. At the point of equivalence, the deep purple color does not disappear. It just turns into a persistent light pink color. At this point, we can declare that the equivalence point has been reached. Let me just reiterate one very important point. At the point of equivalence, both reactants, what I mean by that, the reactants in the burette and in the flask or the beaker are both limiting. Before we reach the equivalence point, the solution in the burette is always limiting. Beyond the equivalence point, the solution in the beaker or the flask becomes the limiting reactant. Now, you simply, at the point of equivalence, like I said, you simply fill or replace the known values into the expressions in order to determine the molar concentration of the Fe2+. Now, throughout the year when we were discussing the titration reactions, ladies and gentlemen, I distributed a great worksheet that simply has a lot of applications on the titration reactions. I solved in class exercises 1, 2, and 3. You have to solve, please, exercises 4, 5, and 6. And throughout this week, I will be presenting you with the solutions for these exercises. Plus, I need to elaborate on the parts that I think are very much challenging or interesting parts of these exercises. I urge everyone to go back to the notes, understand, read and understand, and fully comprehend the concepts of the titration reactions, because they repeat from reaction to reaction. Once you have this done, I want you to resolve the first 3 exercises that I solved in class with you guys. And I want you, on your own, to solve exercises 4, 5, and 6. But, like I said, throughout this week, I will be sending you another video that shows all of the solutions for these 3 exercises, plus some elaborations on the parts of these exercises. Thank you so much. Please, I don't want to just simply talk about it again and again. I want the homework to be done thoroughly and to the maximum. Thank you so much.